In this video, we'll continue our discussion of limits. This one's a bit tricky. So I'm going to, starting this one, algebraically manipulate it a little bit just to help me out in the long run. I don't want to do it here just because it makes sense to do it here. Okay, so we're approaching 1, 0. Let me move this down, actually. You may be able to fit it in there. Okay. This top part, I can factor a 2y out. The bottom part, I can move this y squared, and then what I would have left is x squared minus 2x plus 1. If you factor this, it is x minus 1 squared. This is going to help us out a little later. You can probably see why there. All right, first pass that we should try. Now, this one is not as obvious or as straightforward as the other ones. Like that one's a 1, 0, not a 0, 0. So the path I would want to choose is along the one that makes sense there. It has to go through. So I'm going to pick x equals 1. That straight line will go through the point 1, 0. All right, so let's plug all that in. I got the limit as, okay, if x is 1, okay, we got 1, y approaches 1, 0. And then I'm going to let all my x's be 1. So I got 2y minus 2y. And then I got y squared plus, okay, I got to plug 1 into that. 1 squared is 1 minus 2. Okay, that's just going to be 0 there. I'll put the 0 to help us later. Okay, the limit, I can drop the 1 goes to 1. Y goes to 0, though. And we get a 0 over y squared. I can't plug that in the way it is. So I'm going to go ahead and simplify first. I get a 0, which means the limit is 0. So I'm looking for another path that doesn't go to 0. The easiest one next to check would be the other direction. So I'm going to check along y equals 0. Right, that's the limit as x 0 approaches 1, 0. And plugging in 0, okay, I get a 0 up top. And then I get an x squared minus 2x plus 1. Okay, this is the limit as x approaches 1. Okay, well, I can go ahead and 0 over anything, 0. So my answer is 0. You could use L'Hopital's here if you really wanted to go further. I think this reasoning is good enough as long as you do that. We can't plug it in the way it stood because if I plug in 1, I would get 0 over 0. But if I write it this way, 0 over that, mathematically it's correct. Now, that doesn't help me though. They both go to 0. Okay, I did that algebraic manipulation earlier to kind of make it obvious. And it's not that I saw it, it's just I was wondering what path to choose next. And I'm like, there's a lot of stuff that could be simplified up at the top. And it makes it very obvious what I should sub something for. What I should sub is along the path y equals x minus 1. Now, you have to make sure the point is on there. If I plug in 1 for x, I get 0 for y. So we're good. What told me that was if I look here and I replace that with a y, notice I get 2y squareds on the bottom, and then it also just works out pretty up top. So let's make those subs. So we'll limit, right? And this is going to get rid of the, let's write it down to help us understand it. Okay, so I got x, and then I'll have y as x minus 1, and that's going to approach 1, 0. Okay, so I now can replace all those, and I'm going to use what I had there. I got 2y. Let's think about this. Okay, I think there gets a little tricky. I know where it's going to go, so I'm just going to go ahead and do that. Y goes to 0. And this makes sense because as x goes to 1, this still y goes to 0. Okay, so I'm going to replace all those parts. That x minus 1 right here is going to get replaced with y. And then the same thing on the bottom. I got y squared. I replace x, and I get y squared. All right, that is the limit as y approaches 0 of 2y squared over 2y squared, which is the limit as y goes to 0 of 1, which is 1. We have proven that that limit doesn't exist because one path goes to 0, two paths go to 0, one path goes to 1. So since 0 does not equal 1, the limit d any does not exist. All right. A couple things here to kind of maybe help out because I think I kind of maybe confused you there. This part, how I knew to keep y equals 0 is I knew I was going to keep one of them up here. And then what I did is I just went ahead and thought about if I replaced x minus 1 in this equation with y, which variable would be left. It would be a y, and then I just keep it that y goes to 0. The only thing you have to make sure why you can just do that so freely is you just need to make sure that the point satisfies that equation. Whatever path that you're going along, that it's going to satisfy it. Okay? That is another limit problem. It's kind of tricky.